everyone. I'm Albert Chun. I'm the founder of AI Circle. We're a community of researchers, founders, and operators who are advancing the frontier of AI. And we partner with communities and companies like Centific because they are ushering in the frontier of physical AI. And the reason why we brought this panel together is because in the last few years, what we've seen is the physical AI space go from science fiction to science reality. You know, we've seen it here today with robots like at 1X who are bringing robots to every home, or we're seeing robots in industry and they're folding our clothes and washing our dishes. And I think the real question that we're not really asking is, do robots actually understand what they're doing? Or are they just really adept at pattern matching, and will they collapse when they encounter the randomness of the real world? And so I'm really happy to invite our two speakers who really live within this problem at opposite ends of the spectrum. First, I'd like to invite on stage Professor Wu from Stanford, who helps the industry define what it looks like for robots to understand. And I'd also like to invite on stage Vasu, the Chief AI and Data Officer at Centific, because he's the one who helps scale the data operations to equip these robots to work in the real world. So please give them a round of applause. Amazing. And I'll just give you both a moment to introduce yourselves a bit, and then we'll jump right into our questions. Professor Wu, do you mind?
OK. Hi, everyone. I'm Jiajun. I work on computer vision and robotics research at Stanford. So we build systems that help machines that understand the world, reasoning about objects and scenes, geometry, physics, predict what's going to happen. And then also we work on robotic manipulation that build robots that interact with these objects.
Hey, this is Vasu. I work for Centific. I'm the Chief AI and Data Officer for Centific. Centific is a data infrastructure company that provides high-quality training data and validation for the models and model providers. So very happy to be here.
Amazing. Thank you. And so just to start us off, when we're looking at physical AI, I'd love to ask you both, what do you currently see as the bottleneck? Is it compute? Is it models? What do you see as the bottleneck? Professor Wu?
I guess unlike large language models, everything in the physical world, it's actually much harder to have larger scale data, right? It's like just unlike digital world where you can generate almost infinite data, and users keep producing, and AI models can keep producing data. The high-quality data that you can produce in the physical world is very limited. It is also subject to all these different physical constraints. Extremely high-quality data may be very expensive. So what is the right combination of different types of or different sources of physical data, and how to combine them to allow you to train a model that is really able to scale, I think is still to be figured out.
Yeah, amazing. Yeah, thank you so much. Yeah, so what I'm hearing from you is the major constraint is high-quality data, because the things that you need to balance is what's high quality and what's cost efficient in order to allow these robots to, makes a lot of sense. And Vasu?
Yeah, I agree with Professor Wu, but I would add a nuanced argument on what preventing us from having a high quality data. Currently, the data ecosystem is fragmented.
Yep.
In physical AI, the data has to represent the experience, because the physical AI interacts with the real world, which creates a lot of experience. So creating that experience, which is right now, there is no standardized way, because there are egocentric data, there is manipulation data, the imitation data, or the sensory data, but there is no common standards defined. It is fragmented. Each one is doing the same in a very siloed way. And there is no constant, or there is no standardized eval or a benchmarks that defines the data thing. So these two things is what is going to determine the high quality data that accelerates the physical AI model development.
That's right. Amazing. And Professor Wu, as one of the most cited researchers on the planet, I know that you've done extensive amounts of research around the shortcomings of RGB video data and talking about the importance of multisensory data in terms of sight, sound, touch. What do you think is the reason for the industry kind of still being stuck on egocentric data and video data versus evaluating models based off of multisensory data?
Right. I think the nice thing or the interesting aspects of robotics is you have to deal with data of very different modalities, and they're really heterogeneous, right? There's vision, there could be audio data, tactile data, there could be like a lot of these data about actions, different types of actions, like the torques that you have on your joints. And I think the challenge is like, unlike visual data, or maybe to some extent audio data, where you at least have a shared format, right? I think for other type of modalities like tactile data, we have very different types of sensors, and the type of data they produce are even in different formats, right? There's no like PNG files, just like images. And for action data as well, because you have different robots, they have different number of joints, they're controlled in different ways, and if you have dexterous manipulation like hands, you have different number of fingers. Yep. So what is the right way for us to have a shared data format or data standard? I think that would be a big challenge as well.
Yeah, that makes a lot of sense.
Yep. Yeah, so the Professor Wu touched upon the main point. RGB is one form of data which is primarily captures the visual representation of the data. But as you see, the physical AI has to work in the real world. The real world experience consists of sensory data, and also it has to estimate the weight, the right amount of the pressure, and also it has to predict the navigation to perform a task. And it all needs to be done in a more synchronized manner to produce data. So it not only gets all the sensory data information along with the vision data, which is RGB, but also it has to provide the context that is at which it is operating upon, the environment that is operating upon. And so the temporal value is also a thing, because usually when you actually create a data, it is always on the snapshot. But in a physical AI world, it is continuous. So the temporal aspects of the data has to be synchronized along with the sensory data. And that's what is going to determine the quality of the data to train the physical AI robots in the next few things. So that synchronization on a multimodal is the key for that, because our world is multimodal.
Sure. That's very true. We do live in a multimodal world. Previously you mentioned something about the constraints of cost in order to pursue high quality data. But I guess with the industry pouring hundreds of billions of dollars into data and the infrastructure to power physical AI in the next few years, and when cost is not going to be a constraint, could you talk a little bit about what it looks like to scale a physical AI data, the physical AI data infrastructure layer?
Yes. So the first and foremost thing is standardization of the multi-sensory data, because now every company defines its own schema and its own evaluation mechanism. There is no standardized mechanism for robots to learn or share the experiences across the thing. So that one first thing, if we solve that, the standardization is not an impediment. It is actually a compounding factor. If you really see how the LLM, the digital world has scaled, is because of the standardization, because of the standardization of the benchmarks and the evaluation. That's how the scale happens. So the first part is the benchmark of this thing. Second, we need to invest on the platforms, the annotation platforms it does, right? Because previously, if you do an annotation of a cat or a thing, if you wrongly annotate, the impact is very minimal because it wrongly classifies this thing. But if you actually wrongly annotate a physical AI world experience, that it could be a fatal, okay? So that evolution of the annotation platform with a human validation is very, very important.
True.
And the third one on scaling the data infrastructure is continuously investing on benchmarks, because benchmarks cannot be static, because it has to evolve over the evolving nature and the evolving experiences of the benchmark. These three constraints, if we actually work as a collaboration with academics and the industry, I think the scale, we have the impetus to scale into the next level. So that's the kind of inflection point we are working towards.
Yeah. So some of the researchers that I've met over the years has told me that one bad data point is worth 10 high-quality data points.
Yeah.
And to extend the conversation around high-quality data, I'd actually love to touch on this. I think many people look at data annotation as a bit commoditized. Hey, just get a vendor and label some data, QA it, and just get me good data, right? It seems like anyone can start a data company, but in reality, high-quality data is actually very difficult to achieve in any length of time, especially at scale. And Professor Wu, I'd actually love to hear from you. I know this may get a little technical, but I'd love to hear from you maybe how you think through high-quality data when you are working with a data partner.
Okay. There are multiple aspects. So, there's good data and bad data. There's high-quality data and low-quality data.
Yep.
And sometimes, I think people sometimes confuse the concepts as like, oh, I have a failed attempt. And if the robot, I'm tightly operated robot to do something, or I collect some data, and it turned out, the robot kind of failed. That's not necessarily a bad data. These kind of failure points can also be good data because you actually learn that, how you can recover from failures, right? So there's kind of, successes and failures. They can both be good, but there are also bad data. Bad data are, when you're collecting not very carefully, like for example, the cameras are not calibrated, so then the data itself doesn't allow you to accurately reconstruct the scenes. These are kind of the issues where people may often be not aware of when they just try to mass produce, mass collect a lot of data.
Yes.
Yeah, so you have to be really careful in collecting high quality data of both successful and failed examples.
Yes. Okay. So one, I love that because, what I'm hearing from you is that data quality is not contingent on whether it succeeds or fails at a task. What high quality data is if it gives you a high level of signal over noise to help you train your model.
I think that's right.
Which makes it makes a lot of sense. And to the point of high quality data, I think this is what we're always after, which is crafting the golden data set. And so the ever elusive, perhaps ever refining golden data set, like what does an ideal golden data set look like? And this is a question for both of you.
The quality and the benchmarks are the most important aspects of how fast we can train a model and how reliable the model in the real world is. So the golden data set, it's an elusive problem because for us, it is the difference between a language model and a vision model into a physical model is we are trying to define the physics of it, which is got all aspects of this thing, whether you are not only annotating an object or annotating this thing, but you are actually saying why did it fail? What are all the circumstances? Was the pressure is good enough, or is it exceeded the maximum threshold, or the wide varieties of these things we need to capture to evolve around to arrive the golden data set for the model to perform or not perform. Okay, but it is also high domain specific. It is a combination of robotic engineers plus the actual practitioners who actually practice in a manufacturing setup or in a household task, how they do actually the task and what kind of a pressure they do, how do they estimate a weight, how do they predict the navigation. All of these things has to be captured to create a probable scenario. So to put a point, it's not only supposed to tell what it is, it's supposed to tell why it failed, so that it can learn from the real experience, and then you just train the robots into that. Because that data points, that captured, that becomes the evaluation data set, and with an expert human validation, you can actually do that, okay? There is another aspect of evaluation and a golden data set is synchronization of the multimodal. We touched upon in this previous question about the multisensory, because how do you capture all kind of information with all sensors in a synchronized way with a temporal way? That also defines the golden data set for us. We are not there yet. We have the basic building blocks, but we need to continually evolve that golden data set for the physical AI model.
That's right. Thank you so much. And from your research perspective, what do you think about when it comes to building a golden data set?
Well, I thought it would be, okay, there are maybe a few different aspects.
Sure.
Now, first, and maybe the most important is probably you want to motivate yourself to build data sets for tasks that you actually care about, people care about, right? So instead of like, I think as a common problem for maybe more like researchers building data sets is like, I look at my robot and I was like, what can I do? Oh, I can do these 5 things, and I build a data set for these 5 different tasks, right? But in practice, maybe people care about the other 5 things, and the things you can do is not something that's very useful. Okay. Yeah, so if you can select and design problems, right, based on the tasks that people actually care about, that would be great. Yeah, so that's actually, okay, maybe a small advertisement. That's the motivation behind a large robotic benchmark that we built with Feifei at Stanford called Behavior, that we actually look at the daily activities that people perform and try to collect annotations for these activities. Yeah. And then you can benchmark robot learning algorithms. Sure. Yeah, so one is task selection, and second is high-quality data annotations. If you selected these tasks, then how can you benchmark if the robot is actually successfully cooking dinner or do any of these things for you? Yeah. Right? How can you have the high-quality annotations on the task definitions, on the assets, on the simulation environments, or in the real world? So task definitions, data, assets, and also being comprehensive. So it'd be nice to actually cover a lot of different activities, not just like a few specific activities.
Yep. That makes a ton of sense. So you mentioned Feifei Li, and you're a prolific researcher, and it's clear you care about problems that other people care about here. Would love to hear from you how you see the importance of academic and industry relationships in advancing the frontier. And
right.
This is for both of you. Yeah.
Well, okay. Well, it's kind of funny because I think over the past few years, we always work with different types of industry partners, from startups like Centific, but also to large companies like NVIDIA, Google, Meta, and all these companies you've heard of. But over the past few years, it's interesting that all these big companies, when they still want to do university collaborations, the focus has shifted from doing AI or just building models or computer vision to doing physical AI. Because for AI, they're like, okay, we're going to just use all our resources to train Gemini, so we don't need universities anymore. But then for physical AI, for robotics, right, the problem is not solved yet. There's still a lot of research to be done before scaling things up.
Yes.
So they're like, okay, then why don't we just work together on robotics? Yeah, so I thought that's kind of interesting. So it'd be nice to, I think that big company can still be very helpful in providing resources and also data collection as well, but also compute resources, even if you want to design and benchmark robot learning algorithms. Yeah, so it'd be nice to see more of those.
Yeah. Amazing.
Yeah, so we see the academic collaboration is an essential part of advancing the research labs. As you rightly said, there is no common standard data schema. It is still fragmented. There is no standard evaluation framework. So that's where our research collaboration with academic institute will advance the field. I already told the standards not just impeding the innovation, it accelerates or compounds the adoption because it gives the credibility and it gives the standardization that is required. And we see that as an essential part of this equation.
Yeah, absolutely. Amazing. Well, I guess with just a minute left, I just want to take a time to thank Professor Wu and Vasu for coming on stage and sharing with us. Again, we're so happy to be partnering with companies like Centific who craft these research partnerships to help us advance the frontier of AI and help us think through some of these bottlenecks like data, help us define what good looks like through golden data sets, and help usher in the new frontier of physical AI. So thank you all so much.
Yeah, thank you for the opportunity.
Thank you.
Thanks.
Amazing. Thank you. Thanks so much. Appreciate you. Thanks.
Thank you.
Appreciate it.